talk to you about our machine learning approach to log analytics. Okay, so the problem that we're trying to solve, the problem I'm posing to you, is that of overlogging. Okay, so we see in our clients and our customers that they get billions of logs per week. Okay, it's very good business for us because we provide logging as a service, but for them it's a bit of a problem because the important logs, whatever is critical and relevant to them, just gets lost in the clutter. Okay, so our task is try to surface those logs that are important, that are relevant, and show them to the user, suppressing those that are less relevant. Here he is, among the clutter. Okay, so the approach that we're proposing is using machine learning. Okay, so also going to talk to you about learning and training, but training machine learning algorithms and how we can do this. So the idea of using machine learning to do this task is very promising because machine learning algorithms can go through a lot of logs and sift through a lot of data and not really complain about it. They can look at the data, and you write the algorithms once, and they change them as time progresses. As your data evolves and your training process evolves, so does your algorithms evolve. And you don't have to you write your algorithm again. One small caveat, it does require large amounts of data. And by data, I mean there are two types of data, the data itself, the logs themselves, but also some information about those logs, okay, whether they are relevant or not. It's called labeling data. I'll get to that. Okay, so this is the current state. This is how Kibana looks. In Logs.io, you can go to our booth and see and try to understand what all this is about, but this is how logs look. And not only because of the pixel sampling, but good luck trying to find anything meaningful here. What we really would like to have is just go, okay, Alexa, what's wrong with the production environment? Okay, those of you who did get a dot and reinvent, if you know how to fix the time locale for Israel, give me a call. Okay, so you can do some things with machine learning. We haven't got up to Alexa, what's wrong with my production system, but my God, pixels here are awful. Anyway, so what you see here is a result of a machine learning algorithm that passed through the logs and found a possible memory leak within the logs. Okay, and what's nice about it is that it gives you the log, it gives you a little bit of an example and details about what's going on in there, and also links to other locations on the web and with possible solutions on to solve this problem. Okay. So I said a couple of words about machine learning. I've said that word many, many times. I'll give you a little bit of a taste on what is machine learning, how do you do this. I don't claim to be able, so not all of you, when you leave this room, will be able to train in machine learning, but you'll at least know what the basics are and how to talk to a data scientist, how to solve your problems, okay? So if we're talking about machine learning, they can very roughly be generalized into two classes. That of unsupervised machine learning, which just gets a lot of data and does things like clustering and anomaly detection. You might know algorithms like that. And supervised machine learning, which is predominantly used in classifiers and recommender system, like when Amazon tells you people like you bought this item and people bought this item also bought this very high margin product for us. They're using supervised machine learning to do that. Okay, so if we want to get a little bit into that, so for unsupervised machine learning, for clustering, you don't need a lot. You just need the data itself. Okay, if you look at this example, so there are a lot of data points in here, but basically only 3 relevant clusters, right, represented by the colors. If we take it to the log domain, so a lot of logs, they all look the same, but there are 3 classes here: Apache Tomcat, Nginx, and then some generic log. And you can see that they are all very similar. They are of the same prototype. Okay, this is very useful when you're trying to look at logs. If you are able to look at the prototypes and not at every single log of them, because there are too many of them. Supervised machine learning, a different ballgame. The idea is to learn from examples. Okay, so a couple of examples of machine learning algorithms is, for example, in the automotive industry, like self-driving cars, okay? So a car will have a camera, usually a couple of them, and it has to deduce, are these pixels, are the peak pixels, are they a car, are they a pedestrian, are there a tree, or something along the way. So this is a classifier. A classifier gets a very well put question, and he tries to answer that question, okay? So is this a car in front of me? With regards to email, everybody uses Gmail, right? And Gmail has extremely good spam filters, right? And sometimes you may even tag something as spam or as not spam, right? We all know this, right? Okay, so this is also a classifier. Actually, when you're tagging it, you're actually giving Google the information to improve itself. You're helping Google with the training process, okay? So the problem that we're posing is this log interesting? Okay, is this log relevant? Do I want to see this log? Okay, and the way we propose to do this, and I'm getting really, really deep into the science of it, is we use a machine that's called a support vector machine, SVM. So maybe you've heard these buzzwords before: deep learning, neural networks, support vector machines, Bayesian classifiers. I won't go very deep into this. Suffice to say that you can build a machine, and what you do in order for the machine to answer that question with support vector machines, that you arrange your data in vectors. So for example, you can create a vocabulary of all the words and phrases you see in logs. Okay, so I have an example here. Are you able to read any of this, like the small print? Okay, so the idea is, for example, I took here a vocabulary of 4 words. Okay, so the words connection, error, success, and failure. Suppose these scope the entire words we can see in a log. So if we have a log and it has the phrases connection, failure, so what we do is we just take for every word its respective weight, and those weights were created in the training phase, and we can just sum them up and we get a score. And then we can arbitrarily pass a threshold, and everything, for example, that is above 0 is considered interesting, and below 0 will be non-interesting. Okay, so a log that has connection failure will be deemed interesting, and connection success will be deemed uninteresting. Okay, is this clear, roughly? Some people are nodding. Okay. There is a slight problem here. As I've said, in order to build useful classifiers, they have to have a good question. They have to answer a question that is well posed. And the question of log relevancy is not well posed. Okay? And there are a couple of reasons for that. First of all and foremost is that relevancy is user specific. A log that is relevant to one user may be completely non-interesting to another user, right? And another reason is that people know what they know. Okay, people will find something useful because they ran across it. Like a month ago, they had a showstopper, and they found a problem in the log, and now they know that this log is interesting. But there are a shitload of them just hiding in plain sight within the billions of logs that are there, and they don't know what they don't know. Okay, so they don't know those logs. And so if you're asking a person to give you those logs that are interesting, he will give you those that are interesting. But he doesn't know about the rest. He might just label them incorrectly. Okay, so, and potentially asking people to do this, it's very tedious. Okay, you can't really ask your clients or your engineers to go through all the logs and mark them as interesting or not interesting, right? This is not viable. Sorry. So what we did at Logs.io is we used a couple of methods to get those labels. And one of the most important thing we did was track user behavior. Okay, so if you're looking at your logs, for example, in Kibana, and you're searching for a log and you're opening it, so this may indicate that something is interesting. If you put an alert to it, okay, this is really interesting, right? If you search for something and you just dismissed everything, you didn't look at it, it's not interesting, okay? You get the point. We have a lot of customers. We're doing very well, okay? So we can look at users. Now, every user likes to think of himself as special. His mom told him he's special. We're all snowflakes. We all use the same open source projects, okay? So we can see similarities between users. Okay, so think of every user, every client we have, every company. They have like their crack team of DevOps who know exactly what's good. They know how to fix things. They know what to look for logs. Every company has this team, right? What we can do is look at teams that are different, that are similar, and just merge everything. So think of it as like the amalgamation of all the good DevOps team in the world. So we get all that information. And another way to get good sources for labels is public knowledge bases, from Wikipedia through GitHub up to Stack Overflow. People post logs there, right? So if one person posted a log and 11 people responded, there are 12 people interested. Half of them just want the rank up, but the rest of them, they're really interested in this log. Okay, so they may also propose solutions. So from there you can get things that are interesting and also the solutions. Okay, if we try to put this into practice, what we did at Logs.io, so we have to figure out. So first of all, our data is textual. This is not natural language, okay? It's machine language. This is computer-generated data that is in the logs. But it's textual, it's numerical, alphanumerical. We use classes that have shown good results, are linear support vector machines and random forests. I won't get into this, except to say that if someone is trying to do this, so these are the classifiers that did very well. And what's nice about them that you can really understand the results. Okay, so after the training we did at Logs.io, so we trained it on words and phrases within logs. Okay, so you can see that the words connected, provider, successfully, they all have negative values, indicating that they're not really interesting. The word enable, topic, and error are fairly high. Okay. And what we do when a new log comes in, we just look at the scores for all the phrases, we sum them up, and we get a score. Some of you would say, okay, but look, the word error, that's pretty trivial, right? Obviously, if the word error is in the log, there is something wrong there, it might be interesting. The vocabulary that we trained on is of the order of 700,000 words and phrases, okay? So you might be able to do this on 6 words and get the weights down. You can't really do this a million times, okay? But this is where machine learning algorithms really excel. So if you want to build something like this, so the first thing you need to do is log normalization, which means take the words, lowercase them. So sometimes we see logs like with all caps, right? People are shouting into the log. We want to lowercase them because computer is usually are case sensitive. We stand them so that the word failure and the word fail, they all come from the same root, right? So we use NLP algorithms to bring it to the same root. We identify whatever, the common fields in log. The timestamp is usually irrelevant. The severity may be very relevant. If people use, in logs, many times you'll see stack traces, right? So there are many things that are, a priori, okay? You know the reserved words of languages, so you can take this information and feed it a priori so you get better results. You need a labeler. So you can have different sources for labels. You can go to CQ, community question and answer sites like Stack Overflow and look for logs there. If you have a lot of users, like us, you can take the user interaction and understand what is important. And you can use some heuristics. If you know that, for example, Java stack traces are important to you, so you can, whatever you see a stack trace, you can say that, okay, this is important, and you can build very simple heuristics to get the labeling data. And then you use everything you have, and if you use community question and answer sites, you can even propose solutions to the problems of the users. And this is how the system looks. You take the logs, you normalize them, you feed them with the labels to the machine learning, and then you have a bunch of classifiers ready for you. And all the part on the left, behind the dash, can be done in batch. It can be done offline. It doesn't have to work all the time. The part on the right takes the classifiers, takes the incoming logs, and is able to classify everything in real time. Okay? And this is a system we built. To do this really at scale, we use Spark. Okay, so it drives high throughput. It can handle terabytes of data daily, no problem. And because it is all stateless, we can use spot instances and keep the costs really, really down. So to sum up, if you want to build something, you want to train a classifier, what you have to do is formulate your question well. Okay? It has to be a question that you can answer as a person very, very easily. You have to get enough data. You have to get enough labels, clean everything up, both the logs and the labels, and just train your classifier. Okay? Most of us here use Python, and there are very, very easy packages for Python who will do this for you very easily. And that's it. I've been Ianir from Logs.io. Hope you enjoy.